Hi everyone, welcome to Vishwablooms. In this video, we are looking at the topic vectors, concept 2, class 8 physics techno. Let's begin. This concept is about 2D and 3D representation of a vector and resolution of vector. First, we will look at the topic 2D and 3D representation of a vector. Generally, we all know to represent a point in a graph. Now, we had these kind of 2D graphs, like it contained only x and y axes. So, if this is x axis, this is minus x axis, this is y axis, and this is minus y. So, generally, whenever you wanted to represent a point, you represented in this way. Suppose this is 2 and this is 3. Then you wrote it as 2 comma 3. This thing we all know right now, right? So now we are going to add one more axis, that is z axis and minus z axis. Okay, so now here you observe how the axis will be. I will show you here. This is just for representation purpose. Actually how it is going to be, if you're considering your right side as x, then your left side will be minus x. If you're considering top as y, then the down it will be minus y, and the phone through which you are watching, that will be z axis. Actually it will be coming out from this point. It will be out like this. It will come out of your phone or laptop from wherever you are watching it. It will come out of it. The direction of z axis is outwards. We can't completely show it like this, so we are showing it cross like this. As our paper is 2D, we can't represent the third axis. Okay, so that is about x, y and z axes. Now generally how do we have to represent a point in x, y and z axis? How do we write the coordinates of a point? Generally for x and y axes, we all know, very simple, 2 comma 3. Here first number will represent the coordinate of x axis and second one will represent the coordinate of y axis. So this is abscissa and this is ordinate respectively. So in the similar way, we are going to have z coordinate here additionally. Now for suppose if I am taking a point here in a space, if I am writing it as 2 comma 2 comma 2, then the first number will represent the abscissa, second will represent ordinate, and third will be the coordinate of z axis. Okay, so this is how you are going to represent in 3D. So these all you'll be learning in 3D geometry. Now, so generally you understood, right, how to write this point in a space, that is you will write it as 2 comma 2 comma 2. This is generally. Now in vectors, how do we write? In vectors we introduced 3 directions, okay, for representing the same thing. Instead of writing like a point, we will write it as I cap, j cap and k cap. First I'll introduce the terms. So here they are, I cap, j cap and k cap. So these are the unit vectors. In the first concept we have discussed the types of vectors, where I have told you what is unit vector as well. So unit vector is a vector whose magnitude is going to be 1. Okay, so these things we already discussed in concept 1. So check out the concept 1 video which is in description. Okay, now let's come back here. So I cap is a unit vector in the direction of x axis, okay, and z cap is a unit vector in the direction of y axis, and k cap is a unit vector in the direction of z axis. So in vector form, this is the, now we have seen it already, right? This x coordinate is written as I2 I cap plus 2 j cap plus 2 k cap. Okay, in this way we are going to write for the same points in vector form. Now let's try to understand the same thing with an example. Here I have taken OC as a vector. This is OC vector, I think you can see. This is OC vector. Okay, this is OC vector here. Okay, see, that is covering both x axis, y axis and z axis. Right, now first here is OA vector, this is OB vector, this is OC vector. See, one thing you're supposed to observe, that OA vector is in x-axis, is present on x-axis, and this B vector, OB vector also is present in y-axis. Now how do we write OC vector in terms of these two? First, let me consider this OC vector as A vector as here. Now O is nothing but origin simply. We are coinciding O with origin of coordinate axis. That is why O is given as 0, 0, 0. Right? Now A vector is x, 0, 0 as you can see there. Because it is on x-axis, only x coordinate will be present. Now B is here in xy plane. In xy plane it is present. So B is x, y, 0. That is, the z coordinate of B is 0. Z coordinate is 0. Clear? Next, C vector is x, y, z. That is in this way. Here z is x. Sorry, z is y. So the distance how you will measure is like this. I have drawn a cube here, as you can see, that shows the distance from x-axis, that is x, from y-axis, that is y, and from z-axis, that is z. Okay. Now this vector, how I am going to represent this thing, I'll explain. OC is nothing but OA plus AB, OA plus AB plus BC. In this way you have written that vector. Okay, OA, from here AB, from there BC, in this way. That is what is the representation. So now this x, y, z can be put in vector form as x I cap, y j cap, and z k cap. Okay. Next we have to see the magnitude of the same vector. So the magnitude of any vector is given by, first what you have to do is square these terms, and the root over the square of these terms is the magnitude. Okay, root of x square plus y square plus z square. That's it. Here you can see. Next we will have to understand directions. See, in the first introduction video itself I have told you that vector is something which has both magnitude as well as it has a direction, and then it will follow some vector laws of addition. So vector laws of addition is in the next concept. Okay, in this concept we try to understand the directions as well. Now magnitude and all we understood till here, the magnitude formula. Now we will see directions. See here in this diagram, observe carefully. See, this is OC vector, that is A vector. Here, see here carefully. This is alpha. Alpha is an angle made by the vector A vector and x-axis. Beta is an angle made by A vector and y-axis. Gamma is the angle made by A vector and z-axis. Okay, now these things you should understand. I'll write it here. So what is alpha? Angle made by A vector with which axis? X-axis. Beta is angle made by A vector with y-axis, and gamma is angle made by A vector with z-axis. Okay, these are three things. Now we have to understand few formulae, that is cos alpha, cos beta, and cos gamma. First, cos alpha is given by x by root of x square plus y square plus z square. Cos beta is y by root of x square plus y square plus z square. Cos gamma is z by root of x square plus y square plus z square. Now, how do we understand this formula? From this diagram itself. See, OC vector magnitude, we got it right. What is the magnitude of OC vector? Here it is. OC vector magnitude. That is nothing but this vector magnitude, right? Now for OA vector it is x, OB it is x, y, 0. First try to understand, this is like a hypotenuse and this is like a side. consider like a right angle triangle. Okay, now if you take like that, I'll write with pen. If you take it as a right angle triangle from A, this is x, right? This is root of x square plus y square plus z square. Wait, I will write it again. See here, this was vector OC. Here you had x axis, here you had y axis, here you had z axis. This alpha. See, consider this as a right angle triangle. Now here we had A, right? So this is considered as a right angle triangle. This is here right angle. Now cos alpha, how you will write according to trigonometry? Adjacent by hypotenuse. So this is adjacent, right? So adjacent side is x. Hypotenuse is the magnitude of OC. OC vector magnitude just now we have seen. Root of x square plus y square plus z square. So in that similar way only we will write for cos beta and cos gamma. I hope it is clear. Now one point. So these are called as direction cosines, DCs. And here x, y, z, they are called as direction ratios. So you will study all this in your intermediate and +1 +2 topics. This will be a chapter in mathematics and physics also. Okay, now we need not go in depth to the topics. We will have to just know this formula. Now we'll see the unit vector in the direction of A vector. Okay, vector A. That is given by A cap. A cap is the unit vector in the direction of A bar or A vector. A bar or A vector. So how do you give this? A cap is nothing but A vector by magnitude of A vector. That is nothing but here in the previous example A vector was x I cap plus y j cap plus z k cap. The magnitude will be root of x square plus y square plus z square. That's it. So this is the unit vector. Now this is a small note point, actually very important point. People will forget while solving questions. See, suppose O is the origin of a vector and A is the terminus of that particular vector. See, origin and terminus are the words already explained in concept 1. Those are key words. You should know them. So go and watch concept 1 video in description. Now coming back. See, if I have to find out OA vector, then how do I write this? Simply remember, you are supposed to subtract A vector minus O vector. Remember, some people what they will do, O minus A they will do, but it is wrong. What you have to do is A minus O. If you want to write OA vector, first A you should write, then you will subtract O from it. Okay, don't forget this, very important. So how you will write it? X2 minus x1 I cap plus y2 minus y1 j cap plus z2 minus z1 k cap. Now we will summarize all the points which we have discussed with an example and a graph. Okay, see, and I am going to cover one more point in this as well. If a vector is lying only in xy plane, that is, it is in 2 dimension. If it is in yz plane also, it is in 2 dimension. If it is in zx plane or xz plane also, it is in 2D only. Okay, now for suppose I am considering example as xy vector which is 2D, then here z coordinate will be 0. That means here something will present x comma y comma 0. Here z coordinate is 0. Remember this point. Then how you will express this vector? See, I am telling that the point is x comma y, like this. Then how you will express that vector? A bar will be expressed as x I cap plus y j cap plus 0 k cap, but there is no need because it is not present. So in this way you can simply write that. Okay, now the angles, how you will write? Here the angle made by A bar with x axis is alpha. The angle made by A bar with y axis is beta. Now how do we write the angles between them? Same way we have written previously. So cos alpha is nothing but x by root of x square plus y square. Cos beta is nothing but y by root of x square plus y square. That's it. There is no cos gamma. Okay, because z is 0, right? So it is simply 0. Okay, now we will see tan alpha and tan beta. How can we write? First and foremost thing, all the axes are perpendicular to each other. That means here x-axis and y-axis both are perpendicular to each other. That means the angle between any two axes is 90 degree. That means x-axis, y-axis and z-axis, these three are mutually perpendicular. Remember this point, these are mutually perpendicular. That means x-axis is perpendicular to y-axis, y-axis is perpendicular to z-axis, z-axis is perpendicular to x-axis as well. Okay, I hope this is clear. So now from this diagram you can observe that alpha plus beta is also 90 degree. So 90 degree, how we will write? Pi by 2 in radians. See, if you don't know how to write in radians, then you have to watch trigonometry video, which is there again in our channel, class 8th maths techno. If you see concept 1, you will understand all the different types of systems. Okay, now I am here writing in radians, that is pi by 2 radians. See, now cos, how we have understood, this is adjacent by hypotenuse. These formulas we already studied in trigonometry, right? And this one also same, adjacent by hypotenuse. Okay, like this is adjacent and this is hypotenuse, right? This is hypotenuse. So those magnitudes we have divided, that's it. That is nothing but cos alpha and cos beta. Now how we have to understand for tan alpha and tan beta? Simply, what is the first formula for tan theta? Opposite by adjacent, right? By using this formula only we'll write the formula. By using this basic trigonometric formula we can write it. So tan alpha and tan beta. First I'll explain with tan alpha. This, consider this as a right angle triangle. I'll draw it again. So look at this. Now this will be considered as a right angle triangle. What is tan alpha now? Opposite, that is this side, by adjacent is this side. Now what is opposite? This is nothing but x. Sorry, this is x, this is y. Y by x is nothing but tan alpha. Okay, so look at here once again. This is opposite, right? Opposite is y. This is adjacent. This is x. So simply y by x. And what about beta? Tan beta can be easily found out in this way. See here, alpha plus beta is equal to pi by 2. Beta is equal to pi by 2 minus alpha. Now I will put tan on both sides. So tan beta is nothing but tan pi by 2 minus alpha, that is nothing but cot alpha. So cot alpha is simply reciprocal of tan alpha, right? So cot alpha is x by y, that is nothing but tan beta. Okay, I hope it is clear. Cot alpha is nothing but reciprocal of tan alpha. And here beta is pi by 2 minus alpha. Understand these 2 points, then everything will be clear. Okay, see, if you don't know all this trigonometry formula, then you have to watch trigonometry video completely, then you can come back here. So tan beta is simply x by y, that's it. Okay, now if I have to write alpha, then I will write it as tan inverse of y by x. Okay, when this tan is going to RHS, it will become inverse. Okay, so these concepts you will learn in future. Just I am telling you for information. Tan inverse of x by y. Now the first topic is done, that is 2D and 3D representation is completed. Now we have to see the second topic, which is very important for your future higher classes, that is 11th and 12th or intermediate, whatever it is. It's very very important. Second topic, resolution of a vector, because you will be using it like hell. You know, there is a lot of usage for this topic. Applications are many. So understand this concept right now itself. Even though you'll be taught again later very clearly, but as of now we have to have a basic idea of everything. First, a resolution of vector. What is resolution of a vector? Projection of vector in a particular direction is called component of vector. Before starting off with resolution, first we have to see the topic component. projection of vector in particular direction. That's it. Suppose see this example clearly. Here the vector is in some direction like this, a random direction in this way. Now I want to know what is the projection of this vector in x-axis. Okay, that is why this way I can know that it is represented as ax. Okay, see, now understand till here, then I will tell you the resolution. See, resolution was simply to know the projection in some particular direction, right? But to obtain the components of vector in mutually perpendicular direction is resolution. Components, it can be in any direction, but for resolution it should be in mutually perpendicular directions. Very important point, mutually perpendicular directions. Now for this one, if this angle is theta, then we can write what is ax in terms of a. First consider cos theta. Cos theta is nothing but what? See, again, whenever we are talking about angles, think of a right angle triangle like this. Okay, right angle triangle. Now cos theta is adjacent by hypotenuse, right? So that is ax by a. So what is ax? A cos theta. This is important, very important result. In future you will not be taking in this way, cos theta is equal to ax by. Directly they will be telling you a cos theta is horizontal component. That's it. Now we will try to understand the resolution by the example. Okay. Now for the vector a is equal to xi cap plus yj cap plus zk cap, first and foremost thing you can understand that x is the component of a in the direction of x-axis. X is the component of a in the direction of x-axis. Y is the component of a in the direction of y-axis, and z is the component of a in the direction of z-axis. Okay. Now we'll write the cos alpha, cos beta and cos gamma. See, cos alpha is x by a, cos beta is y by a, cos gamma is z by a. Okay, these things, three things are clear, right? See, again these are from that right angle triangle only. Already I have discussed, right, in 2D and 3D representation. That is why I am not repeating it. Here we wrote as x square plus y square plus z square, right? That is simply nothing but a, the magnitude of a. This can be represented as simply a also, not an issue. So I will put arrow mark for this. So if you are writing it as a vector modulus, that is magnitude, or a, both mean same. This point should be clear by now. Okay, so that is why I have written this. Now how can you write x? X is equal to a cos alpha, y is equal to a cos beta, and here z is equal to a cos gamma. Now from this we can represent this a vector in this way also. Instead of writing x and y and z, simply we can write these things also, right? So now a vector can be newly expressed as a cos alpha I cap plus a cos beta j cap plus a cos gamma k cap. Same thing if I have to write it for 2D. Now I am giving example for 2D. Same thing, okay? Whatever I have discussed just now. If a bar is equal to xi cap plus yj cap, then a is equal to a cos alpha I cap plus a cos beta j cap. Here once again observe the fact that alpha plus beta is equal to 90 degree. Simply I can write it as beta is equal to 90 minus alpha. Now same thing I am going to put here, a cos alpha I cap plus a cos 90 minus alpha j cap. Now a cos alpha I cap plus a 90 minus alpha is, cos 90 minus alpha is nothing but sin alpha j cap. So in this way also we can represent it. Here a cos alpha is nothing but horizontal or x component, and a sin alpha is simply the vertical or y component of a. Now coming to directions of a vector. Directions of a vector. So how do we deal with this topic? Seeing first, what is direction? It is just the spatial orientation. Spatial orientation of a vector. That's it. That is a simple definition of what is direction of vector. Okay. So now how do we give this? See, generally if an angle is given directly without any reference, then you will take it as positive x-axis and anti-clockwise direction. See, I will explain it. Suppose here you have a vector is 60 degrees, suppose it is given, then you will consider in this way that 60 degree is with respect to the x-axis of the vector and it is taken anti-clockwise. Remember, generally all angles are taken in anti-clockwise direction. Remember this. See, clockwise is in this, I'll show you, clockwise in this direction, right? In this way is clockwise, but angles will be taken in this way, that is anti-clockwise. And if there is no mention, they are not mentioned anything, then it is with respect to x-axis. Okay, positive x-axis, that too. Some people might think it is negative x-axis. No, positive x-axis. Clear? Now a doubt might arise to you. Then how do we represent vectors which are like angles like 120, 180, 140? How do we represent them? See, those things you will have to take in this way. Same. Remember one thing, you should always take in anti-clockwise direction. Suppose an angle 120 degrees is made by a vector, then you are supposed to take in this direction, always with respect to positive x-axis only. Understood? Then sometimes what happens is that he will not mention whether the direction is with respect to x-axis or whether it is with y-axis. He will not mention sometimes. So sometimes with respect to the geographical directions he will explain. Okay, what is that? Geographical directions. See, I have taken an example. A vector makes an angle 30 degrees with a direction of east in anti-clockwise direction. Okay, suppose, see, in this way if it is given, right, you should take consideration as mutually perpendicular directions as reference. I'll explain that. It might not be clear for you. See, first you know compass, right? North, south, east and west. You should know this compass. I will write it here. Now in the question, what is mentioned? Suppose in the statement, angle 30 with direction of east. See, this is east direction, right? 30 degrees is being made in anti-clockwise direction. That point is more important. Like this. East, anti-clockwise, 30 degrees. Right? Now how do we say this? Then you should explain the direction as very important point. Note it. Okay, I'll tell. That is, the direction is 30 degree north of east. Very important. North of east. And this is 60 degrees, right? Rest of the thing. 60 degrees east of north. This notation is also important. Okay. See, north of east, that means with east you are going to measure it. 30 degrees. North of east. This 60 degrees with east of north. Okay. Remember these two. Now, how do we understand the angle between two vectors? If there are two vectors like A vector and B vector, then how can we understand the angle? So let's try to determine that. Now first, A vector is like this, which is parallel to x-axis. So this is A vector, this is B vector. See, B vector is making an angle of 120 degree when we consider reference as x-axis. Okay. So what you have to do is, two vectors should be imagined as co-initial without disturbing their direction. Then angle between them, which is less than or equal to 180, is considered as the angle between those two vectors. See, co-initial vectors, in the types of vectors I have already discussed it, so do watch that video. Don't forget to watch that video. If you don't watch that video and watch this, you will not understand anything. Okay. Co-initial vector is nothing but the vectors which will start from same initial point. they are called as co-initial vectors. Okay, see what we have to do, we have to treat them as co-initial, that means join their 2 points, and then the angle between them after joining will be the angle between the two vectors. See, this is not the angle between the two vectors, this is the angle, because less than 180 they ask, no, less than or equal to 180 degree, that should be considered as the angle. So 120 degree is the angle between them. So this is the concept completely. So concept 2 is completed. Now we will move on to the clarity achiever. So we will discuss the clarity achiever and packages in the next video. So that's it for this video. Thanks for watching our video. Do like, share and subscribe.